Hello guys, in today's video we are going to learn the basics of air conditioning system. Let's watch this video.
When we look at a typical refrigeration system, we have the compressor, the condenser, the expansion valve, and the evaporator. The condenser and the evaporator are both heat exchangers. The condenser sits outside the property, and the evaporator sits inside the room being cooled. The compressor circulates a refrigerant in the pipework, which cycles between all of these components. The expansion valve regulates the flow of refrigerant. The refrigerant is a specially designed fluid which can change between being a liquid and a gas very easily. And that's because it has a very low boiling point. For example, refrigerant R410A will boil at negative 48 degrees Celsius, or negative 55 degrees Fahrenheit, although this will change with pressure. But if the refrigerant is inside a pipe within a room, and the room is at 30 degrees Celsius or 86 degrees Fahrenheit, then this will be more than enough to cause it to boil from a liquid into a vapor. So the refrigerant is entering the evaporator as a low pressure, low temperature liquid vapor mixture. It flows on the inside of the pipe, and at the same time, a fan is moving the ambient air of the room over the outside of the pipe. This causes the refrigerant to boil. It will absorb the heat from the air through the pipe wall, and then it evaporates. As the refrigerant evaporates, it carries away the heat. It's similar to when we boil water. The water heats up, it evaporates and turns into steam, and carries this heat away. So the air on the outside is entering hot and it's leaving cold. The refrigerant continues to travel through the evaporator, picking up more heat, which boils it further until it becomes slightly superheated. This basically means it's now completely gas and doesn't contain any droplets of liquid refrigerant. Liquid damages the compressor, so we want to ensure it can't reach the compressor. The compressor sucks in the refrigerant, which is leaving the evaporator as a low pressure, low temperature, slightly superheated vapor. It then squeezes this together into a much smaller space, and so the pressure increases. All the heat which was picked up in the evaporator is now contained in a much smaller volume, so the temperature will increase. This is very important, and we will see why in just a moment. But if you've ever pumped up a bicycle tire, you will notice the pump becomes hotter as it's compressing the air. The refrigerant is then pushed into the condenser, where it enters as a high pressure, high temperature, superheated vapor. The condenser is located outside, and the outside air might be very warm on a summer's day. As heat always flows from hot to cold, we need to ensure that the refrigerant is hotter than the outside air. Otherwise, the unwanted heat will not be able to leave the refrigerant and leave our system. A fan will help to blow ambient air over the condenser to remove this heat. So the outside air is entering warm, picking up heat and leaving hot. As the heat is removed by the air, this causes the refrigerant to condense back into a liquid. It's a little bit like when steam hits the window on a cold day. The window is cold, so it condenses the steam from a vapor into a liquid, and then this liquid starts to run down the window. The refrigerant therefore exits as a high pressure, medium temperature, saturated liquid, and this heads to the expansion valve. The expansion valve needs to regulate the amount of refrigerant entering the evaporator to control this superheat. If it allows too much refrigerant to flow, it can flood the evaporator, so the refrigerant doesn't evaporate and liquid reaches the compressor and possibly destroys it. But if it lets in too little refrigerant, the system won't provide enough cooling, and so it operates inefficiently. The expansion valve regulates the refrigerant by only allowing it to pass through a small hole. This creates a large pressure difference across the valve. One side is the high pressure liquid, the other side is almost empty. The small hole causes it to almost spray into the evaporator as a part liquid, part vapor mixture. the refrigerant will expand to try and fill the empty space on the other side, and this will cause it to drop in pressure as well as temperature. It's a little bit like spraying a deodorant can or a spray paint can. It flows through a small hole, causing it to expand as a part vapor and part liquid mixture, and then we can feel the can become cooler. Now, the original method to control this was by using a fixed orifice device, and you might still find these on the back of your refrigerators. The hole within this device was a fixed size, so the entire system would simply turn on and off to meet the cooling demand. It does work, but we can't maintain a stable temperature control because the system is simply turning on and off. The next evolution was the thermostatic expansion valve. This is still widely used today, and it senses the superheat at the outlet through a bulb which is filled with another refrigerant. This other refrigerant will expand to close the valve when the superheat is too high, and it condenses to open the valve when the superheat is too low. This type of valve needs to be manually calculated and adjusted by a technician. It does work very well, but it's prone to mistakes. It also takes a long time to calculate and set up, and it is also only adjusted once per service visit, which is not ideal. It will also not allow peak performance. However, it does work very well, and these will continue to be used for many years. And so the latest evolution is to use electronic expansion valves. These use a controller to measure the exact temperature and pressure and adjust the valve position automatically in real time to ensure optimal performance and maximum system efficiency.
These are the basics of air conditioning system. Thank you for watching. Please don't forget to follow, like, comment and share the video. Follow our page. If today is the first day you're seeing our video, or you've been seeing our video but you're not following our page, follow our page so that you get more updates anytime we drop a new video. Thank you for watching.